Hello everyone, welcome to Pepcoding. So in this video we are going to discuss the question maximum width of a binary tree. So let us discuss the question. So question says you will be given the root of a binary tree and you have to return the maximum width of the given tree. So second point is the maximum width of a tree is the maximum width among all levels. The maximum width of a tree is the maximum width among all levels. So what this line means that we have to find the width at all levels, and out of that all levels we have to print the maximum width. So third point says the width of one level is defined as the length between the end nodes, that is the leftmost and rightmost non-null nodes. So where the null nodes between the end nodes are also counted into the length calculation. So what this basically means, so we'll be discussing this point in our tree itself. So let's move to our binary tree. So this is our tree, and what the first point says, you will be given the root and you will be given the root and you have to find the maximum width out of each level. So if we talk about levels, then this is the level 0, this is level 1, this is level 2, this is level 3. So there will be some width at 0th level, there will be some width at 1th level, at 2th level and 3th level. So out of all the widths, W0, W1, W2, W3, we have to find the maximum out of it. And what else is discussed? The maximum width of tree is the maximum width among all levels. Width of one level is defined as the length between the end nodes. Okay, so what is the width? Width is the length between the end nodes. If we talk about this level, then these are the end nodes. B and G are the end nodes, and the length between these nodes is the width. And if we talk about this level, level second, then the length between the end nodes, these are the end nodes, then the length between these end nodes is the width of binary tree at this level, width at this level. Okay, and what else is said? The leftmost and the rightmost null nodes. So we have to find the length between the end nodes, and that end node should be non-null nodes. Okay, where the null nodes between end nodes are also counted. So this line says that we have to find the length between the end nodes, and that end nodes should be non-null, means these end nodes can't be null nodes. And the second point is that we have to also count these null nodes. See, in this question G is having null. So if we'll count the width at this level, then the length between these end nodes is how much? 4. See, 1, 2, 3 and 4. This null node will also be counted. We can't say that the width is 1, 2 and 3 only. We can't say this. For this level, the width will be 1, 2, 3 and 4. Null node will also be counted. But if you say that in level 3, in this level, the width will be, this is null, this is null. Okay, and this will be null, this will be null. So if you say that in this level the width will be 1, 2, 3, 4, 5, 6, so this is incorrect. Why? Because we have to find the length between the nodes, end nodes, and that end nodes must be non-null nodes. Okay, so these nodes must be, if this has been non-null, if this has been non-null, then undoubtedly the width had been 6. But since these end nodes are null nodes, so these we can't include these nodes in our width. So for this level our width will be 2 only. Okay, let me visualize one more case to understand more clearly. Suppose this has been a null node and this has been f. Suppose the case is this, then we will calculate the null nodes between the non-null nodes. We will count this null node between the non-null nodes, but and this null. Okay, so in this case our width have been 4, 1, 2, 3 and 4. Okay, so this is what I am trying to say. Let us discuss this same thing, same question in this tree. So for this tree, at this level, 0th level, 1th level, 2th level, 3rd level, so this will be 1. For this width will be 1. For this level width will be 2. For this level width will be null, null, width will be 4. For this level width have been 8. So for this level width have been 8. Okay, so and our answer will be 8 because this is the maximum, and in this level 1, 2 and 4 and 2, so our maximum width will be 4. Okay, so this is what I'm trying to say. Now think of the approach how we will find this thing. See, if we'll talk about width, if we have to index these elements, then this is at 0th index, this will be at 1th index, minus 1, sorry, 1, minus 2 and 2. See, if we have to find the width of this, then this will be 1 for this, 2 for this, 4 for this, 2. Okay, and suppose we have to insert these. See, we will traverse, we'll apply here BFS. We'll apply here BFS. How? See, we will first insert these nodes in our array. So we will, we will create an array and we will insert these nodes in our array. So if we will talk about the position of the nodes, then this array, this node will be at 0th index of array. This will be at 0th index of array. This is 0. And if we have to calculate the index of its child, of A, then how we'll calculate this thing? See, this is at 0th index, and if we have to find the left child index and right child index, let me raise this thing. If we have to find the left child index and right child index, then the formula for this is 2 into parent index plus 1. This will be 2 into parent index plus 2. So if the parent index is 0, then for the left child index will be 2 into parent index, means 2 into 0 plus 1. So this will be 1. Okay. For the right child, formula is 2 into parent index plus 2. So this will be 2 into 0 plus 2. So this will be 2. So index 1 will contain B and index 2 will contain G. Now what we'll do, we'll find the index for child of B. So parent index is 1 and left child index will be 2 into parent index plus 1. So 2 into 1 plus 1, that is 3. And for right child, 2 into parent index, 2 into 1 plus 2, that is 4. For this also, for this null value, indexing will be, see, this will be 3, C, 4 at D. Now we will calculate the index for this null value. This null value will be at 2 into parent index, 2 into 4, 2 into 2, that is 4, 4 plus 1, 5. So 5 will contain null. Okay. And next, 6 will contain H. And now if we'll calculate for these values, null values, so 2 into 3 plus 1, that is 7, will have null. 2 into 3 plus 2, that is 6 plus 2, 8, will have null. And then 2 into 4 plus 1, that is 9. Then 2 into 4 plus 2, that is 10. So 10 will have F. Okay. So this is how array will be containing these nodes. Okay. Now what we'll do for this, we'll create a queue. Now we are discussing the approach. So we will be creating a, let me put this aside. We'll be discussing this tree later on. First we are discussing over this tree. Okay. So what we'll do, we'll create a queue, and that queue will be containing pair of root and indexes. Root and these indexes. Okay. So what we'll do, firstly we'll insert the root value and its index. And then at every point we will be calculating the left child index and right child index. Okay. And what we'll do, we'll remove this A and we will add its left child and right child. So its left child is B and its index will be 2 into parent index plus 1. Right child index will be 2 into 0 plus 1. So at this point index will be, left child index will be 1 and right child index will be 1. Okay. Now we will insert second child, that is right child. So this will be G and this will be 2. So the left child, if we will calculate left child index and right child index for this, then left child index for this is 2 into 0, 2 into 0 plus 1, that is 1. Then right child index is 2 into, let me raise this. Let me raise this thing. So this was 1 and for this right child index will be 2. Okay. So now we will add children of B. We'll remove B and we'll add children of B. And left index will be, see, parent index is 1 for B. For this parent index is 1. So 2 into parent index plus 1. So C will be 2 into 1 plus 1. 2 into 1 plus 1, that is 3. And then this is left children. Now for right children, indexing will be 2 into 1 plus 2. So that is 4. Now its left and right children are added. Now we will remove G and we'll add its left and right children. So this is null. Its index is 5. So we'll not add this null in our queue. We'll directly add this H. So this is H, and for H, left and right index will be, so left index will be, for null it was 2 into parent index was 2. So 2 into 2 plus 1, that was 5 for null. Let it be there. Null with 5. And now we will add H with indexing 2 into 2 plus 2. So right index is 6. So now we will remove C. So okay. So for G, all the children are added. Now what will be done? Now we will remove C and add its children. Remove D, add its children. Okay. And side by side, what we will be doing? We will be managing its width. How we will manage its width? See, if the indexing is 0, then the width is right child index minus left child index plus 1. So for this, right child index is 0, left child index is 0. So 0 minus 0 plus 1. That is its width will be 1. For this, left child index is 1, right child index is 2. Right child index is 2. So 2 minus 1 plus 1. So its width will be 2. See, if we have to calculate the length between two indexes, including that indexes, then the formula for this is ending index minus starting index plus 1. So that will be 7 minus 1, that is suppose 2 to 7. Then 7 minus 2, 5 plus 1, 6. If you can't relate, then see with this 2, 3, 4, 5, 6, 7. These total elements are 1, 2, 3, 4, 5, 6. So this is how we will calculate the length between two indexes. So for this left child index is, for this level, left child index is 3 and right child index is 6. Okay. 3, 4, 5, 6. So width will be 6 minus 3 plus 1, that is 4. For this level, left child index is 2 into 4 plus 1, that is 9. 2 into 4 plus 2, that is 10. So 10 minus 9 plus 1, which is equals to 2. So for this, width is 2. And out of all these widths, maximum width is 4. So this will be our answer. So let us implement this thing in code. Before implementing this thing in our code, let us also discuss the dry run for this tree. Okay. So we will be discussing for this one in fast forward mode, because we have discussed in detail for the previous tree. So indexing is 0. Left child index will be what? 2 into 0 plus 1, that is 1. 2 into 0 plus 2, that is 2. For this, 2 into 1 plus 1, that is 3. And this will be 2 into 2 plus 2. This is left, this is right. For right, 2 into 2 plus 2, that is 6. For this, left child index is 2 into 3 plus 1, that is 7. For this, right child index will be 2 into 6 plus 2, that is 14. Okay. So now if we want to find the width, so for this level, width will be 2 into 2 minus 1 plus 1. For this, 0 minus 0 plus 1, that is 1. For this, 2 minus 1 plus 1, that is 2. For this, 6 minus 3 plus 1, that is 4. And for this, 14 minus 7 plus 1, that is 8. So, and the maximum out of these are 8. So our answer will be 8. So how we'll add this in our queue? We'll add root with its index. Okay. Then we'll remove this, add its left child with its index. It is having no right child. Okay, it is having a right child, that is C. So C with its index. Its index is 2. Now we'll remove B and add its children, that is D with its index, that is 3. Now we'll see its right child. So B doesn't have any right child, so leave it. Now we'll remove C, check its left child. It is having no left child. We'll check its right child. So right child, and its index is 6. And then we have checked the children of C. Now I'll check children of D. Okay. So D is having only left children, that is F, and its indexing is 7. It has no right children. E is having no left children, E is having only right children. So right children of E is G and its indexing is 14. Now we'll check for F. It is having no child, so we'll add nothing. It is having no child, so we'll add nothing. So from here we have received the width 1, from here 2, from here 4, from here 8, because, and out of this is maximum, so this will become our answer. So now we'll be implementing this thing in our code. So we have seen the trirem for 2 trees. So let's move to our code section. So this is our function width of binary tree. Our very first step is we'll create a pair class, and see, we were inserting pair of node and index. So we'll create a class of node and a index idx. So this is our pair class. Now we'll move to our function width of binary tree. Okay, so our very first step is we'll create linked list of pair. We'll implement Q. Q of linked list. So this is done. Now we will add a pair of root, pair containing root, and idx will be 0. So till now we have created the Q and we have inserted root value along with its index. So this part we have done. So our next step is we'll start our while loop. Q dot size is greater than 0. Then we'll do some work. So also we'll check a condition. If root equals to null, then return. So this function will return the integer value. So initially our answer will be containing 0. So this will be return 0 because this function will return integer value. Okay. Now we will get a variable size. We'll extract the size of Q. We'll start a new loop. Size minus minus greater than 0. Also we have to maintain a first index and last index. That was left child index and right child index. Okay, so here we'll maintain first index and in last index. So initially it will be q dot get first q dot get first, and we'll be updating this last index value inside our while loop if it is containing more than one child. So now we'll remove pair one by one. So removed pair equals to q dot remove first also we'll keep this removed pair safely. Why? Because we'll do some work out of it. So this will be rp dot node remove pair. We have extracted the node from the removed pair and we'll do some work in this. Removed pair dot idx. Okay, so we have extracted the extracted the idx value, index value of removed pair, and the node value node of removed pair. So both the things are with us. Now we'll update this last index with this idx. Okay, now we'll check if node dot left not equals to null, then q dot add last new pair, and that pair will be containing node dot right node dot right and left child index. So what was the formula for left child index? It was 2 into parent index plus 1, for right child 2 into parent index plus 2. So parent index is idx over here, so this will be 2 into idx plus 1. Okay, so similarly we'll do for right call also, not call, this will be right child also. This will be node dot right, this was node dot left, 2 into idx plus 2. Okay, and also at the end we'll be comparing our answer with the width. So what was the formula for width? The formula for width was ending index minus starting index plus 1. So here ending index is last index and first index. So this will be last index minus first index plus 1. Okay, and at the end we'll return our answer. So let us run our code to check whether it is working. Okay, so there is some error. Q dot add last node dot left. Okay, so a bracket is expected. Cannot be converted into int. So this is line number 36. Okay, so this function will be returning the pair. So because the Q is containing the pair, so and we need the IDX value out of it. So it will be dot IDX and dot IDX. So long to int. Okay, so this will be long and long, and also it will be int. So from long to int, or there's some error in our pair class. So this will be of long data type. Now let us run this. Okay, so there is some more error. This is L1. So this will be Li. So this will be Li. Okay, so let us submit it. Okay, everything is working fine. So I hope you have understood the question and the solution. So we'll be meeting in another video with another question. So thank you for watching.